Hey physics friends, and welcome to me solving this worksheet. I'm going to take you step by step through every single problem, kind of giving you strategies on how to do these, giving you strategies on how to organize yourself. And so when you go through, if you have questions, you can watch different parts. I'll let you fast forward whatever you need to get to whatever questions that you have when you're going through this video. So let's get started. So this very first one, we are given a position versus time graph, and we're asked to make the velocity and the acceleration. So whenever you go from this graph down, you're going to use the slope. And whenever you go from the velocity to the acceleration, you're also going to use the slope. Now, the slope of each section, so what I'm going to do, like right below each section here, I'm going to say the slope. So the slope m of this section is 0. This section right here, the slope is the rise over the run. So this goes down, it looks like 8, and goes over 1. So this has a slope of -8. And then this section has a slope of up 4 over 1, 2, 3. So this has a slope of 4/3, or 1.3 repeating. So now I go to put that onto my velocity versus time graph. Now the slope is what the velocity is. It's not how much it changes. So the velocity over this entire interval is 0. It's not moving. So what the slope everywhere on this line is 0. So that's what the velocity is right there. This slope is -8, so I got to change my axes. I'm going to say -8, -4, 4 and 8, so I can just make this fit on here. And then 4/3 is 1.3 repeating, so I just go up to 1.3 repeating and make my line. And I'm just kind of guessing. I'm not really being really super accurate and so on. And then lastly, when I go from my velocity to my acceleration, it's also the slope. And it turns out the slope of each of these is 0. So then there is no acceleration. And that kind of stands to reason. In this first piece, you're not moving, so there's no acceleration. You're going at a constant speed, so there's no acceleration. And you're going at another constant speed, no acceleration. So over all of these intervals, there is no acceleration. Hence why the acceleration is down here at 0 the entire time. My next one. Now this one, in this case, let's see if we can get this to focus a little bit better. Whenever you go from this graph to this graph, we're going to use the area. And then remember that the area, it's how much it changes. Area equals the change in position. And that's a really big idea. I get a lot of people that are very confused with that. Now, I'm going to be doing areas in red and blue. Like if it's a positive area, I'm going to do it in red. And if it's a negative area, I'm going to do it in blue. So first off, you always go from 0. So this area right here is below the axis. So the area is base times height divided by 2, because this is a triangle. So I take 1 times 2, which is 2, and half of that. So this area is equal to 1, a -1. My next area, it's this triangle right here. So I just break it into simple geometric shapes. And it's above the axis. So I take the base, which is 2, and the height, which is 4. 2 times 4 is 8. Half of that, this area is equal to +4. Now I have a rectangle right here. This area is base times height, so 4 times 1, and that area is equal to 4, +4. And then lastly, this area, it's nothing because you go from 0, so then this area is equal to 0. Now what these represent is how much your position changes. So I can start over here no matter where I want. So I'll just start at 0 to kind of make the math simple. So if I start at 0, I need to change -1. So I end up right here at -1. What I'm going to do, once I find my areas, then I'm going to do the connect the dots. So once I know how much it changes, let's put it, I know it's got to go to -1. And then right here, I know it's got to go +4. So if I'm at -1, and if I go +4, I end up here at 3. And then I go another 4. So if I'm at 3, that means I end up at 7. So I'm up here at 7 right now. This is at 3. This is at -1. And then the last one's 0. My change is 0. So I stay at 7. Now I'm going to fill these, I'm going to connect these dots with the appropriate curve. So this is a positive slope, so it's a happy face. So I'm going to connect these with a happy face. And another positive slope. Continue on with my happy face. And you could even write curved up. If you feel like you're like, oh, I don't know if you can tell that this is curved, you can just write curved. That's not a big deal. And then this is a constant velocity, so you're going at a constant rate, so that's a straight line. And then a constant, you're standing still, like that. So again, some of the techniques that I use to keep all this mess straight. Number one, I use different colors. If you don't have different colors, make arrows. Always go from 0 up to your area, so you know that this is a positive area, negative area. Once you have your areas, start putting dots down. I started with 0. I change -1, and then I change +4, and then I change another +4, and then I change 0. So remember that the area is always the change in the position. Last, now if I want to go from this graph to this graph, it's the slope. So what I do, over this whole first 3 seconds, they all have the same slope. So what I'm going to do, this goes up, this goes from -2 to +4, so this goes up 6. So the slope, it's +6 over 3 seconds. So this has a slope of 2. These last two pieces have a slope of equal to 0. So I have right here at 2 and 0. The slope is what the acceleration is. The slope is, the area is the change. So what this is saying is that my velocity is changing 2 meters per second every second. And that makes sense. So if I start out here at -2, after 1 second, I'm up to 0. After another second, I'm up to 2. After another second, I'm up to 3. I am changing velocity 2 meters per second every second. That's what 2 meters per second squared means. It means you're getting 2 meters per second faster every second. All right, let's go down to the third one. Again, when I go from this graph to this graph, I'm going to use the area. So, get out my pens, and here is my first area. It's below the axis. It's a triangle. So that is base times height. So 3 times 4, that's 12. Half of that is equal to -6. So then this area here is 1 times 4, half of that. And then at the end, there is no area right here. This area equals 0. So remember, the area is how much it changes. So if I start out, and if you do a little foresight, I got to go -6 and -2, and that's going to be -8. So it's going to go off my graph. So I'm just going to change my axes. I'm going to make this -4, and I'm going to make this -8. So this is 4, and this is 8. And that way I can make the graph fit. So if I start at 0, and you can start anywhere, I have to go to -6. I change 6, so I'm here at, right there, at -6. And then I go -2 more, so then I end up at -8. And then I change 0. So here's my connect the dots. found my areas, put my dots, and now I connect them with the appropriate line. This is a sad face because it's a negative slope, so I'm going to connect these with a sad face. This is a happy face because it's a positive slope, so I'm going to connect it with a happy face. Happy face. Sad face. And then I'm going to connect these lines with a horizontal line because you're standing still. So there, put my numbers in, -6, -8, -8, just so if anyone's wondering where I put that, you have an idea. Now, when I go from this graph to this graph, it's the slope. So, finding the slope of this first section, this slope looks like it goes down 4 over 3, which is -1.3 repeating. This slope looks like it's going up 4 over 1, so this has a slope of +4. And then this slope right here in this section, this slope is equal to 0. So, let's see, I have a -1 1/3. Then I go up to a slope of +4, and then I go to 0. So here is my graph. Remember that the slope is what the acceleration is. The area represents how much it changes. So there's number 3. Let's go to number 4. And remember, we'll go up this way, and this is the area. So I'm going to bust out my colored pens. So here's my first one, and this is above the axis, so it's a positive area. So it's 1 times 4, so this area is a +4. And this is below the axis. So this area is 1 times 2 is a -2. This area is above the axis. You can see where this red and blue kind of helps. So it's 1 times 2, so this area is a +2. Now you have a complex shape. I'm going to break this into a rectangle and a triangle, and I'll just add them together. So this rectangle is 2 times 1, so this rectangle is a +2. This triangle is 1 times 4. Half of that, that's also a +2. So this whole area is a +4. And then lastly, for my last bit, this area is equal to 0 because it's right on the axis. So now, after I find my areas, I'm going to do the connect the dots. So again, I like to start at 0. You do not have to start at 0. I'll start it at 0. And then I go up +4. So I go up to +4. And now I go -2. So I go 2 down, 2 in the negative direction. Remember, the area represents the change. So if you're at 4, you're changing to +2. And now I changed +2 more. So I'm back up here at 4. This puts me at 2. We'll go to 4. And now I changed 4 more, so I'm up here at 8. So I have to be up here at 8. And then I don't change at all. So I leave and I stay here at 8. So here's my dots that I have to now connect. So I have a constant velocity, and that's a straight line. Constant velocity, straight line. Constant velocity, straight line. Now, happy, I have a increasing speed, so this has to be happy, curving up, and then constant velocity, like that. So there's the correct graph for number 4 for the position versus time. Now we'll go down here, and this is going to be the slope. So I take the slopes of all these. So the slope of 0, 0, 0. I only have a slope right here. All these slopes are equal to 0. This has a different one, and this slope is also equal to 0. So this goes up 4, right? It goes from 2 to 6, up 4 over 1. So this slope is equal to 4. So I'm going to have 0, 4, 0. Remember that the slope is what the acceleration is. On to number 5. When I go from this graph to this graph, it's the slope. And again, when I go from this graph to this graph, it's also going to be the slope. So in both of these cases, I'm going to be using the slope. So this goes, it looks like it goes up 6 over 2. So 6 over 2, this slope is equal to 3. The slope is equal to 0. This slope, it goes down, let's see here, 2, 4, 6, it goes down 8 over 1. So this slope is equal to negative 8. And then this slope, it's positive 2 over 1, so that is positive 2. I think, I got a negative 8. It's not going to quite fit. So I think I'll go negative 4, negative 8, 4, 8, and then 4, 8, 12. So I'll just adjust my axes so you can see it. So the slope represents what it is. So I'm at 3. And then I'm at 0. And then I'm at negative 8. And then I'm at positive 2. Like that. So there's my velocity versus time for this graph. Next, we'll take the slopes. So this has a slope of 0, 0, 0, 0. These are my favorite. Last question. Number 6. When we go from this graph to this graph, this is the area. So I'm going to bust out my colored pens again. And I go, this has 2 times 1, so this area is positive 2. This area is a positive 1. This area right here is a 0. And this area is below the axes. So this is 2 times 4, which is 8. Half of that is negative 4. Now remember that it's below the axis, so you have a negative number. Now I do my connect the dots. Put it at 0, and I go positive 2. Then I go up positive 1, so I go 1 more. Remember that the area always represents the change. So I'm up to 3. I'll just write that there. Now I stay at 3, because my change is 0, and now I'd go to 4. So I should end up at negative 1, like this. Now I connect the dots. Constant velocity, so straight line. Constant velocity, straight line. Constant velocity, straight line. Speeding up. So this is a sad face. So you're going to speed up by showing you have a larger slope at the end. And then my very last one, we're going to use the slopes. Slope 0, 0, 0. So all of these have a slope equal to 0. And then this last section has a slope. It looks like it goes down, what is that? Down 4 over 2. So this has a slope of negative 2. So I'm at 0, 0, 0, and then negative 2. Remember that the slope is what the acceleration is, and the area is how much it changes. All right, friends. Hopefully this is helpful to you. And if you have more questions, please don't feel free to ask. I can give you more of these. I can make them up on the fly. I want nothing more than to help you. I know this stuff is really confusing the first few times you see it, and it was for me when I learned it too. So hang in there, stay positive, keep working at it, and we'll talk to you later.